Welcome to part 2 of our lesson on conditional probability and the general multiplication rule. I have on here the computation of these probabilities using that general multiplication rule. If we have small random samples taken from large populations without replacement, aka less than 5% of the population size, the events would be assumed independent. And we can have two events E and F being independent if the probability of E given F is equal to the probability of E. Again, these matching. Or equivalently, the probability of F given E is equal to the probability of F. Again, these matching. Then the probability of E and F is just essentially probability of E times the probability of F. So the multiplication rule for independent events is a special case of our general multiplication rule. So because of that, we can verify whether two events are independent or not. So example number 5. I have here the following data represents the number of different communication activities used by a random sample of teenagers in each week. We want to know are the events female and 0 activities independent. So we have 2 checks here to make. This is the probability of these 0 activities given that person was female. So for 0 activities given that that person was female, we have here 22 of those activities divided by, since we are given that the individual for this was female, that would mean that we are dividing now based upon the total number of females in this sample to be 200. So 22 divided by 200, that's 11 over 100. And we also want to check the probability of being female. Right? For us, let's see. Actually, we don't want to do the female one yet. We want to check the probability of 0 activities. So let me apply that on here. So 0 activities. So for 0 activities, there's a total of 44 over a total of 400 total activities. This reduces to 11 over 100. These two match, which is good. We can also check the flip side. This is the probability of being female given 0 activities. So again, there's 22 females for the 0 activities section here. Out of a total of 44 0 activities, that reduces just to be 1/2. And now the probability of being female, right? There's a total of 200 females out of a total of 400 total people. That's also 1/2. So both of these are also equal. So what does that mean? That means yes, the events of female and 0 activities are independent. Based on this example that we used for this. And we have one more of these examples. Suppose you purchase a digital music player and have put 7 songs on it. After listening to these, you decide that you like 3 of the songs, which is, not the best, but what can you do? With the shuffle feature on your player, each of the 7 songs is played once in random order. We want the probability that among the first 2 songs played, you like both. So this is the probability that you like the first times the probability that you like the second, given that you like the first. So there's 3 songs that you like out of a total of 7. So the probability of liking the first is 3/7. But liking the second, given that you like the first, after choosing the first, there are now a total of 6 songs left. And since you already chose one that you liked, there's only 2 left that you like now. So 3/7 times 2/6. This gives us a fractional amount of 1/7, or as a decimal, 0.1429, about 14%. Is this unusual? No, it is not unusual. Right? It's nowhere near 5%. So because of that, it's not unusual. How about if you like neither of them? So that means this is the probability that you do not like the first times the probability that you do not like the second, given that you do not like the first. So since you liked 3 of the songs out of the 7, that means there's 4 out of the 7 that you did not like for the first song. And again, same idea. You chose one song already out of 7 songs, now there's 6. And since one of them you did not like, that means now there's only 3 left that you did not like out of 6. So 4/7 times 3/6. This is 2/7, or a probability of 0.2857. 28%. About. An increased amount there. And then the last one of you like exactly one of them. So to find that probability of liking exactly one of them, we could use the complement rule for this. This is 1 minus the probability that you like both of them minus the probability that you like neither of them. So 1 minus, this will be 1/7 minus 2/7. So this would give us a remainder of 4/7, or as a decimal, 0.5714. So much greater probability that you like only one of them. Let me know if you have any questions or concerns. Thank you.